The topic of this video lesson is congruence transformations. We're going to say that two geometric figures are congruent if and only if there is a rigid motion or a composition of rigid motions that maps one of the figures onto the other. Now, just a reminder from before, rigid motions are motions that preserve length and angle measure of a shape. Congruent figures have the same size and the same shape. The figures here are congruent because they have the same size and shape. These ones on the right are not congruent because they have different sizes or shapes. All right, example 1. Identify any congruent figures in the coordinate plane and explain. So figures are congruent if they have the same size and same shape. Okay, so, and they can have a composition of rigid motions that map one to the other. So let's take a look. So take a look at the image here. Do you see any images or any shapes that are congruent? I do. I see here this square, quadrilateral ABCD, and this square, quadrilateral QRPN. And I can see that these are congruent. Okay, so I'm going to say ABCD is congruent to, and then note we have to go in the same order. So I went A, B, C, D. So I'm going to go NPQR. It's congruent to NPQR. And then we are going to describe a rigid motion that takes us from one to the other. So we're going to look from Q to C. We see that's most definitely a translation. So we're going to say that there is a translation. And it doesn't really matter which one we go to, if we go from NPQR to ABCD or vice versa. Let's go in the direction that we've written our statement. So we're going to say translation, our vector will be left 2, down 1, 2, 3, 4, 5, 6. Okay, so our rigid motion is our translation that takes us from our first quadrilateral to our second. All right, so let's take a look. Is there another? All right, we can see that this triangle right here and this triangle right here also appear to be congruent. Now, what type of transformation would connect these two? So we can see that triangle EFG is congruent to triangle KLM, and this is a reflection over the x-axis. And we can see that because the points are mirrored. All right, are there any others? All right, so we can see that there's one more. That triangle HIJ and triangle UTS are also congruent. So triangle HIJ is congruent to triangle UTS. And this most definitely is, it looks like a rotation. specifically a 180-degree rotation about the origin. And we can see that because if we look at point U, which is at 5, -3, and we look at point J, which is at -5, 3, we can see that they're opposite. All right, now it's your turn. Identify any congruent figures in the coordinate plane, and then explain. Compare your answers with the neighbor. Pause the video here to do this, and then continue. Another name for a rigid motion or a combination of rigid motions is congruence transformation, because the preimage and the image are congruent. Example 2. Describe a congruence transformation that maps parallelogram ABCD to parallelogram EFGH. All right, so note here that our preimage and image are our two parallelograms, and that the matching vertices must land in the same location after our composition of transformations. So we know that we need to get A to land on point E. So this point here needs to land here, and we need to figure out a series of movements that will make that happen. All right, so here's what I'm thinking. Let's start with a reflection. And let's reflect this figure over the x-axis. In doing so, we get A prime here, B prime here, C prime 3 away, so 1, 2, 3, C prime's here, and D prime 2, 3 here. And so we get this here, and we'll see that that's our reflection. So our first one we're going to say is reflect ABCD over the x-axis. Then we need to take it and we're going to shift it. Now the problem is this does not line up correctly. So remember what I said before is I wanted A to be E. So what that means is my move, it didn't work. So let's try that again. All right, so the reflection of it over the x-axis was not the way to go. So how about we instead try to reflect it over the y? And let's see if that helps us. So that puts A here. And actually, I think that's already going to be better. So A is here. B is here. D is here. And C is here. Then, so that's a reflection. So we're going to reflect A, B, C, D over the y-axis. And now we're going to translate it down. Let's see. 1, 2, 3, 4 units. So translate A, B, C, D using our vector. We're not going to move horizontally, so 0 and then down 4. And that will get us from ABCD to EFGH. All right, now it's your turn to try. Describe a congruence transformation that maps JKL to M and P. Note, J must land on M after the series of transformations. Pause the video, give it a try, compare your answers with your partners. All right, now here's some practice problems. Go ahead and grab a textbook and please work on problems 3 through 10, 25 to 28, and 37 to 42. This is our 4.4 homework. And then if you have any questions, feel free to message me. All right, thank you.